The sphere appears without warning, drifting silently above the rain-soaked field. Witnesses describe it as roughly the size of a grapefruit, though some swear it was as large as a beach ball. It glows with an otherworldly luminescence, casting shadows that dance and flicker across the ground below. The color shifts as you watch, transitioning from electric blue to amber gold, sometimes settling into a pure white radiance that seems almost alive. It moves with intention, floating against the wind, hovering near metal objects, passing through walls as if they were nothing more than mist. And then, just as inexplicably as it arrived, it vanishes in a burst of light or simply fades from existence, leaving behind the sharp scent of ozone and a profound sense of unease. This is ball lightning, one of nature's most puzzling spectacles, and its mysterious cousin, the spooklight. For centuries, these glowing orbs have appeared in thunderstorms and remote locations around the world, defying our attempts at explanation and challenging everything we think we understand about the physics of our atmosphere. They represent a fundamental mystery that sits at the intersection of documented science and unexplained phenomenon, reported by credible witnesses whose testimonies we cannot easily dismiss. The accounts come from pilots navigating through turbulent skies, scientists working in laboratories, military personnel on night watch, and ordinary people who happen to be in the right place at the wrong time. These are not stories from the superstitious past alone. They continue today, adding new chapters to a mystery that spans cultures, continents, and centuries. What are we actually seeing when these glowing spheres manifest before our eyes? Are they purely natural phenomena that we simply haven't yet decoded? Are they atmospheric anomalies that occur under conditions so specific we've barely begun to map them? Or do they represent something that genuinely challenges our current understanding of physics itself? This is the question we'll explore together, following the evidence wherever it leads us, examining both the folklore that has grown around these lights and the science that attempts to explain them. We'll journey through documented cases that have puzzled investigators, delve into historical accounts that stretch back hundreds of years, and consider the modern explanations that researchers are currently testing in laboratories around the world. The truth, as we'll discover, may be stranger and more fascinating than either folklore or conventional science alone can fully capture. On a clear night in the high desert of West Texas, about 9 miles east of the small town of Marfa, something extraordinary happens with enough regularity that the state has built an official viewing platform for it. Travelers pull off Highway 90 into a designated parking area, complete with historical markers and interpretive plaques, to witness a phenomenon that has puzzled observers for more than a century. They come armed with cameras, binoculars, and smartphones, settling onto the observation deck as the sun descends behind the distant Chenadi Mountains. And then, as darkness claims the vast expanse of Mitchell Flat, the lights begin their nightly performance. The Marfa Lights, as they have come to be known, appear as glowing orbs of various colors, most commonly described as white, yellow, orange, or red, though witnesses have reported blues and greens as well. They manifest above the desert floor, sometimes hovering in place, sometimes moving horizontally across the darkness with apparent purpose. What makes these lights truly perplexing is not merely their appearance, but their behavior. Witnesses consistently report watching single lights split into multiple orbs, merge back together, fade from view entirely only to reappear moments later in a different location. The lights dance and bob, sometimes moving in ways that suggest random wandering, other times executing movements that seem almost choreographed. They can remain visible for seconds or for hours. Some nights they appear bright and active, putting on what regular observers call a good show. Other nights, they barely materialize at all. The documented history of the Marfa Lights stretches back to 1883, when a young cowboy named Robert Reed Ellison was driving cattle through the area. According to the account that has been passed down through generations, Ellison observed strange lights flickering in the distance and assumed they were Apache campfires. When he mentioned the lights to other settlers in the area, he learned that local ranchers had seen the same mysterious illuminations, but had investigated and found no evidence of camps, no remains of fires, no explanation whatsoever for the glowing phenomena on the distant plain. What strikes researchers and casual observers alike is the consistency of the reports across the decades. The lights Robert Ellison saw in the 1880s are described in remarkably similar terms to the lights witnessed by visitors in the 21st century. This historical continuity gives the Marfa Lights a credibility that many unexplained phenomena lack. We are not talking about a single strange event or a brief flurry of unusual sightings. We are talking about a persistent mystery that has defied explanation for over 140 years. The town of Marfa itself has embraced its connection to the mysterious lights with a mixture of civic pride and entrepreneurial spirit. What began as a quirky footnote in local lore has evolved into a genuine tourist attraction. The official Marfa Lights viewing area, established by the Texas Department of Transportation in 2003, includes restrooms, picnic tables, and educational displays about the phenomenon. The town hosts an annual Marfa Lights Festival each September, drawing visitors from across the country who hope to witness the lights and celebrate the mystery that has put this remote desert community on the map. Local businesses incorporate the lights into their branding and marketing. Gift shops sell Marfa Lights memorabilia. The phenomenon has become woven into the cultural and economic fabric of the region. But beyond the tourist attraction and the festival atmosphere lies a genuinely puzzling scientific question. What are these lights, and why do they behave the way they do? The explanations offered over the years range from the mundane to the exotic, and none has achieved consensus among researchers or satisfied the many witnesses who insist that what they have seen cannot be explained away so easily. The most commonly cited conventional explanation attributes the lights to automobile headlights from Highway 67, which runs roughly parallel to Mitchell Flat, some distance away. According to this theory, atmospheric conditions in the desert create a superior mirage effect, bending light rays and making distant car headlights appear as floating orbs. Proponents of this explanation point out that the modern proliferation of sightings coincides with increased automobile traffic in the region. They note that the lights typically appear along a horizontal plane consistent with a distant roadway. However, this explanation immediately runs into problems when confronted with the historical record. Robert Ellison saw the lights in 1883, decades before automobiles appeared in West Texas. Throughout the late 1800s and early 1900s, before car traffic became common in this remote region, ranchers, railroad workers, and travelers consistently reported seeing the mysterious illuminations. Unless we are willing to believe that the phenomenon changed its fundamental nature to conveniently match the introduction of automotive technology, the car headlight theory fails to account for the historical continuity of the sightings. Other researchers have proposed that the lights result from the ignition of phosphine and methane gases rising from the desert floor. This swamp gas theory has been invoked to explain various mysterious light phenomena around the world. The idea is that decomposing organic material in the soil releases gases that spontaneously combust when they reach the oxygen-rich surface air, creating brief flashes of light. While this might explain random, short-lived illuminations, witnesses to the Marfa Lights describe sustained displays lasting minutes or hours, with lights that move deliberately across significant distances and perform complex maneuvers. The swamp gas explanation seems inadequate to account for the full range of reported behaviors. Atmospheric phenomena, including temperature inversions, ball lightning, and piezoelectric effects from stressed rock formations, have all been suggested as potential explanations. Temperature inversions can indeed create optical effects in desert environments, bending light in unusual ways. Ball lightning, though still not fully understood by science, might produce glowing spheres that float and move. Certain types of geological stress can generate electromagnetic phenomena that manifest as visible light. Each of these theories has merit, and each might explain some subset of sightings under specific conditions. But the witnesses who return to the viewing platform night after night, some of whom have observed the lights for years, insist that what they see exhibits a complexity and variety that resists any single simple explanation. The most intriguing aspect of the witness testimony is the consistent description of seemingly intelligent behavior. People report lights that appear to respond to observation, that move in coordinated patterns, that exhibit what observers describe as playful or curious movements. A light might approach the viewing area, then retreat. Multiple lights might move in formation, maintaining consistent spacing as they traverse the desert. Lights split apart and rejoin in ways that witnesses insist look deliberate rather than random. Of course, the human tendency to perceive patterns and attribute intention to natural phenomena is well documented. We are pattern-seeking creatures, evolved to detect agency in our environment because assuming intention where there is none is safer than missing a genuine threat. A random movement of lights across a dark landscape might easily be interpreted as purposeful by an observer primed to see something mysterious. The dancing and merging of the lights might result from multiple mundane light sources at varying distances, creating an illusion of interaction when in fact they are completely independent phenomena. Yet the sheer number of witnesses, many of them repeat observers familiar with the desert environment and its normal visual phenomena, gives pause. Local residents who have lived in the area for decades and watched the lights countless times are often the most adamant that something genuinely unusual is occurring. These are not tourists hoping for a supernatural experience or casual observers misinterpreting something they have never seen before. These are people who know the landscape, who are familiar with how car headlights look at various distances, who have seen mirages and heat shimmer and all the normal optical effects of the desert environment. And they insist that the Marfa lights are different. Scientific studies of the phenomenon have been surprisingly limited given its accessibility and historical prominence. A study conducted by the Society of Physics students in 2004 concluded that the lights they observed could be explained by vehicular traffic on nearby highways. However, this study has been criticized for its limited observation period and for not accounting for historical sightings or the full range of reported behaviors. The researchers observed lights that correlated with traffic, but whether these were the same phenomena that witnesses find so compelling remains an open question. What makes the Marfa lights particularly significant in the catalog of unexplained phenomena is precisely this accessibility and historical continuity. This is not a case of blurry photographs or secondhand stories. Anyone willing to drive to West Texas can visit the viewing area and potentially see the lights for themselves. The phenomenon occurs in a specific, well-defined location and has done so reliably for generations. This combination of accessibility, consistency, and historical documentation makes the Marfa lights one of the most scientifically approachable mysteries in the field of unexplained phenomena. The lights persist, dancing above Mitchell Flat, as they have for more than a century, indifferent to our theories and explanations. Whether they represent a complex interplay of mundane atmospheric and automotive light sources, an undiscovered natural phenomenon, or something that resists easy categorization, they continue to draw the curious to this remote stretch of desert. The viewing platform fills with observers as darkness falls, each hoping to witness the mystery for themselves, to add their own account to the long history of perplexed testimony. And more often than not, the lights oblige, appearing in the darkness, moving and merging and dancing across the vast Texas night, offering no answers, only the perpetual invitation to wonder. Deep in the Appalachian Mountains of North Carolina, along a ridge that cuts through Burke County like an ancient scar, something rises from the darkness that has defied explanation for centuries. The brown mountain lights appear without warning on clear nights, glowing orbs of reddish or white luminescence that drift upward from the ridgeline, hover for moments that stretch into minutes, then vanish as mysteriously as they arrive. What makes these lights particularly unsettling is not just their appearance, but their persistence. They have been witnessed by thousands, documented by scientists, investigated by the government, and yet they remain, stubbornly unexplained, a luminous mystery that challenges every theory we construct to contain it. The Cherokee people knew these lights long before European settlers arrived in the region. According to their oral traditions, the lights were the torches of spirit maidens searching eternally for their warriors who had died in a great battle with the Catawba tribe on Brown Mountain itself. The women would climb the ridge each night, holding their flames high, calling out names that would never be answered. It's a haunting image, one that speaks to grief that transcends death, to loyalty that outlasts the physical world. The Catawba had their own interpretation. They believed the lights were the spirits of Cherokee women still searching, but in their telling, it was not loyalty but curse, a punishment for some ancient transgression that bound them to endless wandering. These weren't just stories told around fires to frighten children. The lights were real, observable, part of the landscape itself. When German engineer Gerhard Wildebrandt surveyed the region in 1771, he recorded seeing the lights and noted them in his official documents. This may be the earliest written account by a European observer, though it certainly wasn't the last. By the late 1800s, the lights had become something of a local phenomenon, attracting curious visitors who would gather at various vantage points, hoping to witness the spectacle for themselves. What they saw was consistent enough to establish a pattern. The lights typically appeared on clear nights, usually after dark, but occasionally during twilight hours. Witnesses described them as spherical or oval, ranging in color from soft white to deep red or orange. They would rise slowly from the ridge, sometimes singly, sometimes in groups. The orbs would hover, drift laterally along the ridgeline, then either fade gradually or blink out instantly. Most peculiarly, they could be seen from multiple observation points miles apart, suggesting they were neither small and close nor simply tricks of perspective. The consistency of these reports across decades and centuries is what elevates the Brown Mountain lights from folklore into genuine anomaly. By the early 20th century, the lights had attracted enough attention that the United States Geological Survey decided to investigate. In 1913, they dispatched a team led by geologist D.B. Stewart to determine once and for all what was causing these mysterious illuminations. Stewart approached the investigation with the methodical skepticism expected of government scientists. He spent weeks in the area, interviewing witnesses, establishing observation posts, and documenting every light he could verify. His conclusion, published in the official USG's report, was disappointingly mundane. The lights, he determined, were nothing more than the headlights of locomotives traveling through the Catawba Valley and automobile headlights on roads south of Brown Mountain. Atmospheric conditions and the mountain geography, he argued, created a kind of natural refraction that made these distant lights appear to float above the ridge. It was a tidy explanation, one that fit neatly into the scientific understanding of the time. There was only one problem. In 1916, a massive flood swept through the region, destroying both the railroad tracks and the roads that Stewart had identified as the source of the lights. For weeks, no trains ran, no automobiles traveled those routes. The infrastructure was gone. And yet, on clear nights, the lights continued to appear exactly as they always had. Local residents watched them drift above Brown Mountain's ridge with the same ethereal quality they had always possessed. Whatever was creating these lights, it clearly predated the invention of the automobile and the locomotive, and it persisted regardless of human activity in the valley below. This development prompted a second investigation in 1922, this time conducted by the Smithsonian Institution. Their team was led by a physicist who approached the problem with fresh eyes and updated equipment. His methodology was more rigorous than the USGS study. He established multiple observation stations, synchronized timing systems, and attempted to triangulate the position of the lights using geometric principles. What he discovered only deepened the mystery. The lights, when they appeared, did not correspond to any known light source in the area. They seemed to originate from the ridge itself or from the air above it. His final report acknowledged that the phenomenon was genuine and unexplained, though he stopped short of proposing any alternative theory that might damage his scientific credibility. Over the following decades, the lights continued to manifest, and theories proliferated to explain them. One persistent hypothesis involved swamp gas, the spontaneous combustion of methane, rising from decaying organic matter. It's a phenomenon known to create ghostly lights in marshland areas, so-called will-o'-the-wisps, that have their own rich folklore. However, Brown Mountain and its immediate surroundings contain no swamps, no significant wetlands where methane might accumulate in sufficient quantities. The geology is wrong, the terrain is wrong, and the behavior of the lights doesn't match the erratic flickering typically associated with swamp gas combustion. Another theory focused on piezoelectric effects. The mountains of North Carolina contain significant quartz deposits, and when quartz crystals are subjected to mechanical stress, they generate electrical charges. Some researchers propose that seismic activity, even minor tremors too small for humans to feel, might cause stress in underground quartz formations, generating electrical discharges that manifested as visible light. It's an elegant theory with real physics behind it. Piezoelectric effects are well documented and understood. The problem is, that the lights appear with no correlation to seismic activity. They don't cluster around earthquake swarms or follow fault lines. They appear on calm nights when the Earth is still, and they're absent during periods when seismographs record actual tremor activity. In more recent years, plasma formation has emerged as a favored explanation among some researchers. This theory suggests that unusual atmospheric conditions over the ridge might create pockets of ionized gas, glowing plasma similar to ball lightning or St. Elmo's fire. Plasma can indeed create luminous effects that hover and drift, and it could explain the various colors witnesses report. However, plasma formations typically require specific conditions: high electrical fields, storm activity, or significant electromagnetic disturbances. The brown mountain lights appear on clear, calm nights when none of these conditions are present. They show a level of consistency and predictability that random plasma formation cannot account for. Park rangers who have worked in the area for years tell a different kind of story, one grounded not in theory but in repeated observation. One ranger stationed near the Wiseman's View Overlook, one of the prime observation points for the lights, described watching them on dozens of occasions over a 15-year career. He spoke of how they would rise slowly, almost deliberately, how they seemed to respond to the landscape itself, following the contours of the ridge rather than drifting randomly. He noted that they appeared most frequently during autumn months, though not exclusively, and that they seemed more common during certain phases of the moon, though he couldn't establish a definitive pattern. What struck him most was their consistency. These weren't random flashes or misidentified aircraft. They were a reliable phenomenon that he came to expect and respect, even if he couldn't explain them. Local residents, families who have lived in the shadow of Brown Mountain for generations, speak of the lights with a mixture of pride and unease. They're proud that their mountain holds a mystery that scientists can't solve, that their home harbors something genuinely unexplained in an age where everything seems mapped and measured. But there's unease too, a subtle discomfort that comes from living near something fundamentally unknown. One woman whose family has farmed land near the mountain for 5 generations described watching the lights as a child with her grandfather. He told her the old Cherokee stories, but he also told her about his own experiences, nights when the lights appeared close enough that he could hear a faint humming sound, a vibration that he felt in his chest rather than heard with his ears. She herself has seen them more times than she can count, and each sighting carries the same strange quality, a sense that she's witnessing something that exists outside normal categories of experience. What creates such profound unease about the Brown Mountain lights is precisely this resistance to explanation. Each scientific theory that emerges seems plausible until you examine it closely, until you compare it against the actual observations accumulated over centuries. The lights should be headlights, but they predate automobiles. They should be swamp gas, but there are no swamps. They should be piezoelectric discharges, but they don't correlate with seismic activity. They should be plasma, but they appear in conditions where plasma shouldn't form. Every explanation crumbles when confronted with the stubborn reality of the phenomenon itself. This pattern of failed explanations creates a particular kind of epistemological vertigo. We live in an era where we believe, perhaps naively, that science can ultimately explain everything, that mystery is simply ignorance waiting to be illuminated by sufficient research and technology. The Brown Mountain lights challenge this comfortable assumption. They suggest that our explanatory frameworks might be incomplete, that nature might harbor genuine anomalies that don't fit neatly into our categories. That possibility is both thrilling and terrifying, because it opens a door we thought we had closed, admitting the possibility that the world remains fundamentally mysterious in ways we haven't accounted for. The lights continue to appear, indifferent to our theories and our need for certainty. They rise from the ridge on clear nights, drift along paths only they understand, and vanish back into darkness. Thousands have witnessed them. Scientists have studied them. And yet, they remain precisely what they were when the Cherokee first saw them centuries ago, lights in the darkness that refuse to be explained away. A luminous reminder that mystery persists even in the mapped and measured world we think we've created. The air in Professor Georg Wilhelm Richmann's laboratory crackled with anticipation on the 6th of August, 1753. Outside his St. Petersburg home, Dark clouds gathered as an afternoon thunderstorm rolled across the Russian capital. For Richmond, this was not a moment for caution, but opportunity. Here was his chance to probe the mysteries of atmospheric electricity, to measure and quantify the invisible forces that split the heavens with fire. He had spent months perfecting his apparatus, a device he called an electrical indicator, which would draw lightning's power down through a metal rod and into his laboratory where he could study it safely. Or so he believed. Richmond was not some country mystic dabbling in folk magic. He was a respected member of the Russian Academy of Sciences, a physicist who had published extensively on thermodynamics and electrical phenomena. When he noticed the approaching storm through his window that August afternoon, he immediately summoned his assistant, an engraver named Sokolov, who was there to document the experiment with detailed illustrations. Together they positioned themselves before the apparatus, Richmond standing barely a foot away from the vertical rod that extended through his ceiling to the roof above. The storm intensified. Thunder rolled across the city. Richmond leaned forward, observing his instruments with the focused attention of a trained scientist at the threshold of discovery. And then, without warning, the apparatus discharged. But what emerged was not a simple arc of electricity, not the expected spark jumping between conductors. According to Sokolov, who survived to tell the tale, a pale bluish sphere of fire, roughly the size of a man's fist, detached itself from the metal rod and floated through the air directly toward the professor. Richmond had no time to react, no moment to step aside or cry out. The glowing ball struck him squarely in the forehead, and in that instant, one of Russia's most prominent scientists fell dead to the laboratory floor. The sphere itself vanished as mysteriously as it had appeared. Sokolov, standing just feet away, reported feeling a powerful shock that knocked him backward, but he survived with only minor injuries and temporary paralysis. When other members of the household rushed to the laboratory, they found Richmond lifeless, a reddish mark burned into his forehead where the luminous sphere had made contact. One of his shoes had been blown apart by the force of the electrical discharge. The incident sent shockwaves through the European scientific community that rivaled the lightning bolt itself. Here was a credible witness, Sokolov, describing something that defied easy explanation. Here was physical evidence, a body bearing the unmistakable marks of electrical trauma. And here was the unsettling suggestion that lightning could manifest not just as bolts from cloud to ground, but as independent spheres of energy that moved with apparent purpose through enclosed spaces. Richmond's death became a cautionary tale, yes, but also something more. The first scientifically documented encounter with what would eventually be called ball lightning, purchased at the ultimate price. For more than 2 centuries after Richmond's death, reports of similar phenomena accumulated in scientific journals, ship's logs, military records, and eyewitness testimonies. Yet the scientific establishment remained skeptical, dismissing most accounts as misidentifications, optical illusions, or the confused recollections of frightened observers. How could such a thing exist? What physical mechanism could sustain a sphere of plasma or electrical energy that floated freely through the air, sometimes for minutes at a time, defying everything known about how electricity behaves? Then, in 1963, something remarkable happened aboard a commercial flight that would provide one of the most detailed and credible observations of ball lightning ever recorded. The witness was not a frightened peasant or an excitable amateur, but Professor Roger Jennison, a respected British physicist and electronics expert from the University of Kent. Jennison was flying from New York to Washington during an evening thunderstorm when the aircraft entered a particularly turbulent patch of weather. The plane was a passenger jet, cruising at altitude, and Jennison was seated in the cabin when he noticed the other passengers growing agitated. A bright flash filled the aircraft, followed almost immediately by an audible thunderclap that suggested the plane itself had been struck by lightning. But what happened next transformed a routine lightning strike into something far stranger. According to Jennison's detailed account, published later in the journal Nature, a glowing sphere approximately 8 inches in diameter emerged from the pilot's cabin and began floating down the aisle toward the rear of the aircraft. Jennison watched, transfixed, as this luminous ball drifted past him at a steady pace of roughly 3 feet per second. He described its appearance with the precision of a trained observer. The sphere was bluish-white in color, uniformly bright across its surface, with clearly defined edges and no apparent internal structure. It emitted a faint hissing sound as it moved, barely audible above the aircraft engines, but distinct enough for those nearby to notice. Most remarkably, the sphere seemed completely indifferent to the aircraft's motion, maintaining a straight path down the center of the aisle as if it were moving through still air rather than the cabin of a jet traveling hundreds of miles per hour. The entire observation lasted approximately 10 seconds before the sphere reached the rear of the passenger cabin and simply vanished, disappearing as suddenly and inexplicably as it had appeared. Jennison later calculated that the ball had traveled roughly 30 feet during its visible journey through the aircraft. He noted that it left no scorch marks, no residual heat, no lingering effects of any kind. Several other passengers witnessed the phenomenon, providing corroborating testimony that matched Jennison's own observations in every essential detail. What makes Jennison's account so compelling is not just his scientific credentials, but the clarity and specificity of his description. This was not a vague light, glimpsed peripherally, or a brief flash misremembered years later. This was a sustained observation by a physicist who understood the importance of accurate reporting and had no professional incentive to fabricate or embellish. His account included measurements, estimates of luminosity, color descriptions, and behavioral notes that would prove invaluable to researchers attempting to understand this baffling phenomenon. As investigators began compiling reports from credible sources, patterns emerged from the chaos. Ball lightning, as these phenomena came to be called, displayed certain consistent characteristics across hundreds of independent observations. Size varied, but most witnesses described spheres ranging from a few inches to about 2 feet in diameter, with basketball-sized globes being particularly common. The color palette included nearly every hue: red, orange, yellow, white, blue, and occasionally green or violet. Some observers reported uniform coloring, while others described shifting, swirling patterns within the sphere itself. The sounds associated with ball lightning proved equally varied. Many witnesses reported a hissing or crackling noise, similar to the static discharge from high-voltage equipment. Others described buzzing, humming, or even a peculiar silence that seemed unnatural given the visible energy on display. When the spheres disappeared, they did so in different ways. Some simply faded from view like a dying ember. Others vanished instantaneously, winking out of existence with no transition. Still others exploded with varying degrees of violence, from gentle pops to concussive blasts that shattered windows and knocked observers off their feet. Perhaps most unsettling was the phenomenon's apparent ability to pass through solid matter. Multiple credible witnesses, including trained military observers and experienced pilots, reported seeing ball lightning penetrate walls, closed windows, and even the metal fuselages of aircraft without leaving visible damage. The spheres seemed to exist in a state that defied normal physical constraints, moving through our material world while somehow remaining separate from it. The behavior of ball lightning appeared maddeningly unpredictable. Some spheres drifted lazily on air currents like dandelion seeds. Others moved with apparent purpose, following corridors, descending staircases, or tracking along metal surfaces as if drawn by magnetism. Witnesses reported spheres that bounced off solid objects like rubber balls, and others that passed through the same materials like ghosts. Some moved in perfectly straight lines while others wobbled, spiraled, or executed seemingly random course changes that suggested, disturbingly, something approaching agency or intent. This unpredictability extended to the danger posed by ball lightning. While many encounters ended harmlessly with the sphere simply vanishing, others resulted in severe burns, electrical shocks, fires, or explosions. There seemed to be no reliable way to predict which spheres were benign and which were deadly. A ball lightning event might drift peacefully through a room full of people before dissipating without incident, or it might suddenly discharge its energy with lethal force, as poor Richmond discovered in his St. Petersburg laboratory. Military records from World War II contain numerous accounts of ball lightning appearing in aircraft, submarines, and ground installations. Bomber crews reported glowing spheres materializing inside their aircraft during thunderstorms, sometimes floating benignly through the fuselage, other times causing electrical systems to malfunction or explode. These were not impressionable civilians or attention-seeking storytellers. These were trained military personnel, pilots and navigators, who had every incentive to report accurately and no professional benefit from fabricating wild tales. The credibility of witnesses became a central issue in the scientific debate surrounding ball lightning. When a farmer claimed to see a glowing orb in his field, skeptics could dismiss it as misidentification or rural superstition. But when airline pilots, university professors, military officers, and meteorologists reported identical phenomena under controlled circumstances, dismissal became more difficult. These were individuals trained in observation, accustomed to making accurate reports under stress, and often professionally obligated to document unusual events with precision. Yet despite this accumulation of credible testimony, ball lightning remained stubbornly resistant to scientific study. Unlike regular lightning, which could be predicted, photographed, and even artificially generated in laboratory settings, ball lightning appeared spontaneously, unpredictably, and almost always in circumstances that made controlled observation impossible. Researchers could not summon it at will, could not reproduce it reliably, and could not capture specimens for analysis. It appeared and vanished on its own inscrutable schedule, leaving behind only confused witnesses and, occasionally, physical evidence in the form of burn marks, electromagnetic anomalies, or inexplicable damage to materials. This combination of credible witnesses and impossible behavior created a profound tension in the scientific community. Here was a phenomenon that seemed to violate fundamental principles of physics, yet came supported by testimony from individuals whose professional credibility was beyond question. The dangerous, unpredictable nature of ball lightning only intensified this tension. This was not some harmless curiosity to be studied at leisure. This was a potentially lethal phenomenon that could appear anywhere, at any time, following no discernible rules, capable of passing through walls and killing with a touch. Understanding it was not merely an academic exercise. It was a matter of public safety, of protecting pilots and passengers, of preventing deaths like Richmond's from being repeated in laboratories and homes across the world. Global Resource Version. Adapted Reservoir. Sampling. In a remote valley in central Norway, where winter darkness stretches for months and the northern lights dance overhead, something else illuminates the night sky. The Hessdalen Valley, a sparsely populated region about 120 kilometers south of Trondheim, has become the most intensively studied spooklight location on Earth. Here, unlike anywhere else in the world, mysterious aerial phenomena aren't just witnessed and whispered about. They're measured, recorded, and tracked by an array of scientific instruments that have been watching the skies continuously for more than 4 decades. The valley itself is a place of stark beauty. Mountains rise on either sides, their slopes covered in pine and birch, creating a natural corridor roughly 12 kilometers long and 5 kilometers wide. Fewer than 200 people live here permanently, scattered across farms and small homesteads that have belonged to the same families for generations. These residents grew accustomed long ago to the lights that appear without warning, sometimes hovering motionless above the valley floor, sometimes racing across the sky at speeds that seem to mock the laws of physics. But what began as local folklore transformed into rigorous science in 1983, when a group of Norwegian and Swedish researchers launched Project Hessdalen. Led by engineer Erling Strand, this initiative represented something unprecedented in the study of unexplained aerial phenomena. Rather than relying solely on eyewitness accounts or waiting for sightings to occur, the team established the first permanent, automated monitoring station designed specifically to detect, track, and analyze these mysterious lights. The timing was deliberate. During the winter months of 1981 through 1984, the valley experienced an extraordinary surge in activity. Lights appeared multiple times each week, sometimes as many as 20 observations in a single night. Residents reported seeing glowing orbs of various colors, brilliant white, deep red, golden yellow, sometimes changing hue as they moved. The lights displayed behaviors that defied conventional explanation. They would appear suddenly, hover in place for minutes or even hours, then accelerate to impossible speeds before vanishing. Some descended nearly to the ground. Others split into multiple objects or merged together. Witnesses described feeling both awe and unease as these luminous visitors performed their silent ballet overhead. The early Project Hessdalen expeditions brought serious scientific methodology to bear on the phenomenon. Researchers deployed multiple cameras, loaded with different types of film, spectrum analyzers to measure the wavelengths of light being emitted, magnetometers to detect electromagnetic disturbances, radar systems to track movement and velocity, and seismographs to record any associated ground vibrations. They established observation posts on both sides of the valley, allowing for triangulation of the light's positions and accurate measurement of their altitude and distance. The instruments began capturing data that would fill scientific papers for years to come. Radar returns showed objects traveling at velocities exceeding 30,000 kilometers per hour, then stopping abruptly or reversing direction in ways that would subject any physical craft to forces measuring hundreds or thousands of times the acceleration of gravity. No known aircraft, no drone, no balloon could perform such maneuvers. The spectrum analysis revealed something equally puzzling. The lights emitted across a broad range of wavelengths, sometimes showing spectral signatures consistent with ionized gases, other times displaying characteristics that didn't match any known light source. Erling Strand, a methodical engineer who approached the mystery with scientific caution, rather than sensationalism, has spent more than 40 years studying these lights. His testimony carries weight precisely because of his reluctance to speculate beyond what the data supports. He describes nights when the monitoring equipment detected approaching lights, tracking them as they moved through the valley. On several occasions, he and his team witnessed the phenomena firsthand, watching through instruments as luminous objects hovered nearby, sometimes within a few hundred meters of their position. But perhaps most intriguing are the accounts of apparent interaction. Strand and other researchers have reported instances where the lights seem to respond to human presence or activity. During one observation session, team members directed a powerful laser pointer toward a distant light. Within seconds, the light began moving toward their position, approaching until it hung suspended in the air less than a kilometer away. When they switched off the laser, the light resumed its previous path. They repeated the experiment. Again, the light altered its trajectory, moving toward the laser's point of origin. These weren't isolated incidents. Multiple researchers, across different years and different teams, have reported similar experiences. Bjorn Gittelhauge, a Norwegian computer engineer who joined the project in the late 1990s, described an encounter where a bright light appeared to pace their vehicle as they drove through the valley, maintaining a constant distance and altitude regardless of the car's speed or direction. When they stopped, it stopped. When they proceeded, it followed. The experience lasted nearly 15 minutes before the light suddenly shot upward and disappeared. Such accounts create profound unease because they suggest something beyond simple natural phenomena. A lightning ball or atmospheric plasma doesn't track vehicles. It doesn't approach laser pointers. These reported interactions hint at something responsive, perhaps intelligent, though researchers carefully avoid making such claims without definitive proof. The data shows correlation. The lights appear to react to specific stimuli, but correlation isn't causation. And the scientific method demands extraordinary evidence for extraordinary claims. In 1998, Project Hessdalen established its first fully automated monitoring station, a breakthrough that transformed intermittent research expeditions into continuous surveillance. The station operates year-round, equipped with multiple cameras, a magnetometer, and computer systems that automatically detect and record anomalies. This automation solved a fundamental problem. Human observers can only watch for limited periods, but these lights appear on their own schedule, often during the darkest hours when winter temperatures plunge far below zero. The automated systems have captured hundreds of events. Time-stamped photographs show luminous objects at various altitudes and distances. Video footage reveals lights pulsating, changing color, and moving in patterns that seem purposeful rather than random. Thermal imaging cameras have detected heat signatures that don't match any conventional source, objects radiating at temperatures inconsistent with their apparent size or the environmental conditions around them. The electromagnetic data adds another layer of mystery. Magnetometers frequently register disturbances, coinciding with light appearances, sudden fluctuations in the local magnetic field that begin when a light appears and cease when it vanishes. Radio frequency monitors have picked up unusual emissions, broad-spectrum noise that some researchers speculate might be related to the light's propulsion or energy source, though this remains purely hypothetical. Scientists from multiple institutions have joined the effort over the decades. Italian researchers from the National Research Council conducted studies in 2001, deploying additional instruments and analyzing the spectroscopic data. Their findings confirmed the earlier Norwegian observations. The lights were real, measurable, and deeply anomalous. Japanese scientists, British physicists, American engineers all have spent time in Hessdalen, drawn by the opportunity to study a phenomenon that appears reliably enough to permit systematic investigation. Several theories have emerged, each attempting to explain all or part of what the instruments record. The ionized iron dust hypothesis suggests that dust particles containing iron and scandium, blown up from the valley floor or eroded from the surrounding rocks, become electrically charged and luminous under certain atmospheric conditions. Laboratory experiments have shown that such particles can indeed produce light when ionized, and geological surveys have found the requisite minerals in the valley's bedrock. But this theory struggles to explain the light's extreme velocities and apparent maneuverability. Dust particles, even ionized ones, don't accelerate to 30,000 kilometers per hour. They don't hover motionless against the wind. They don't reverse direction instantaneously. The piezoelectric hypothesis offers another avenue. The rocks beneath Hessdalen contain quartz and other crystalline minerals that generate electrical charges when subjected to stress. Tectonic movements, subtle shifts in the Earth's crust, could theoretically create these stresses, producing electrical discharges that ionize the air and create luminous plasma. This would explain why the lights appear more frequently during certain periods, times when tectonic stress builds and releases in cycles. Yet, this too leaves questions unanswered. Piezoelectric effects are typically localized and brief, small sparks or corona discharges, not large, sustained lights that persist for minutes or hours. And again, the movement patterns don't fit. Plasma formed by piezoelectric discharge wouldn't chase vehicles or approach laser pointers. Some researchers have proposed that Hessdalen might host a rare atmospheric combustion process, perhaps involving sulfur compounds or other reactive gases seeping from the ground. Under the right conditions, these could ignite and create luminous balls of burning gas, similar to the will-o'-the-wisps reported over marshlands. The valley's unique geology and topography might create conditions where such combustion occurs more reliably than elsewhere. But chemical combustion requires fuel and oxygen. The lights have been observed at altitudes where oxygen is thin, and no one has detected the chemical signatures that burning sulfur or methane would produce. The thermal signatures also don't match combustion. Fires radiate heat in predictable ways, but some of the Hessdalen lights show thermal characteristics that seem inverted or inconsistent with burning. A more recent theory involves quantum processes and exotic physics, suggesting that the valley's specific combination of geology, magnetism, and atmospheric conditions might create temporary regions where conventional physics behaves unusually. Localized plasma vortexes, miniature atmospheric dynamos generating their own electromagnetic fields, could theoretically explain both the lights and their apparent ability to move against gravity and inertia. This hypothesis ventures into speculative territory, proposing mechanisms that haven't been fully proven in laboratory conditions, much less in open air. But it has the advantage of potentially accounting for the full range of observations, the extreme velocities, the electromagnetic effects, the thermal anomalies, even the apparent responsiveness if these plasma structures interact with external electromagnetic sources like lasers or radio emissions. What becomes clear after 4 decades of study is that no single theory fits all the facts. Each hypothesis explains certain aspects while failing to account for others. The Hessdalen lights may not have a single cause. Perhaps multiple phenomena occur in the valley, some instances caused by ionized particles, others by piezoelectric effects, still others by processes not yet understood. This uncertainty, persisting despite rigorous scientific investigation, creates a particular kind of intrigue. We want mysteries to yield to patient study and careful measurement. We expect that instruments and data will eventually reveal the truth behind any natural phenomena. But Hessdalen challenges this expectation. The more we measure, the more questions emerge. Every answer reveals deeper puzzles. The valley continues its vigil. Cameras watch the sky. Sensors monitor the electromagnetic spectrum. Automated systems stand ready to capture whatever appears next. And researchers, driven by scientific curiosity and the human need to understand our world, keep analyzing the data, proposing new theories, and returning to this remote Norwegian valley where something inexplicable continues to light up the darkness. On a stormy evening in ancient China, during the reign of Emperor Qin Shi Huang, around 230 years before the Common Era, court chroniclers documented a peculiar phenomenon that would perplex observers for millennia to come. Glowing spheres of light, they wrote, descended from tempestuous skies and drifted through palace courtyards, moving with apparent purpose before vanishing without trace. These luminous orbs were not mere lightning bolts, but something altogether stranger, floating, persistent, and seemingly alive. The court scholars interpreted them as messages from the celestial realm, perhaps warnings from ancestral spirits, or communications from the gods themselves. This ancient record represents one of humanity's earliest documented encounters with what we now call ball lightning, a phenomenon that has been witnessed, feared, and misunderstood across every civilization throughout recorded history. The Chinese were meticulous in their astronomical and meteorological observations, driven by a belief that heavenly phenomena directly influenced earthly affairs. In texts dating back to the Warring States period, between 475 and 221 before the Common Era, these accounts speak of glowing spheres appearing during thunderstorms, ranging in size from a human fist to a large cooking pot. The chroniclers noted how these mysterious lights would sometimes enter homes through windows or doors, drift slowly through rooms, and occasionally cause damage by igniting materials they contacted. What makes these ancient Chinese records particularly valuable is their consistency and detail. The observers noted colors, behaviors, and effects with remarkable precision, creating a documentary foundation that would echo through centuries of subsequent reports. Across the ancient world, the Greeks and Romans encountered similar phenomena, though they clothed their observations in different mythological frameworks. The Greek historian Pliny the Elder, writing in the 1st century of the Common Era, described what he called flying stars that appeared during storms. He documented cases where luminous spheres were observed during military campaigns, sometimes interpreted as omens foretelling victory or defeat. Roman chroniclers noted instances of glowing orbs appearing above temples and public forums, events that were invariably analyzed by augurs and priests for divine meaning. In 77 of the Common Era, the eruption of Mount Vesuvius that destroyed Pompeii was reportedly accompanied by numerous sightings of mysterious lights and floating luminous objects, phenomena that witnesses interpreted as the gods themselves fleeing the catastrophe or perhaps warning the doomed inhabitants. The ancient world's interpretation of these lights was inextricably linked to religious and spiritual belief systems. When a glowing sphere appeared, it was not merely a natural curiosity, but a manifestation of divine will, a breach in the barrier between mortal and immortal realm. This interpretive framework makes perfect sense when we consider that early civilizations had no concept of atmospheric electricity or plasma physics. A floating ball of light that could pass through solid walls, change direction without apparent cause, and disappear in an instant defied all understanding of the physical world. It had to be supernatural because no natural explanation seemed remotely plausible. As we move into the medieval period, the documentation of these phenomena becomes richer and more detailed, though still heavily filtered through Christian religious framework. European chronicles from the 9th through 15th centuries contain numerous accounts of fireballs entering churches during services, an occurrence that terrified congregations and was invariably interpreted as either divine visitation or demonic manifestation. In 1103, the Anglo-Saxon Chronicle recorded an event in Winchester where a ball of fire entered the cathedral during evening prayers, moved down the central aisle, and exited through a window, leaving several worshippers unconscious but otherwise unharmed. The chronicler interpreted this as a sign of God's displeasure with certain ecclesiastical practices then under debate. Medieval castles also featured prominently in ball lightning accounts. Stone structures with metal fixtures and limited windows created environments where these phenomena were both more likely to occur and more likely to be contained and observed. In 1238, French chronicles describe an incident at Château de Chinon, where a luminous sphere approximately 1 foot in diameter entered the Great Hall during a thunderstorm, circled the room 3 times, struck a suit of armor, and exploded with a sound like a cannon, leaving the metal blackened and partially melted. Guards who witnessed the event swore they could hear a humming or buzzing sound emanating from the sphere as it moved. Such detailed sensory descriptions, even when wrapped in supernatural interpretation, provide valuable data points that align remarkably well with modern eyewitness accounts. The religious framework through which medieval observers interpreted these events shaped not just their understanding, but also their emotional responses. A glowing orb entering a church could be an angel, a soul in purgatory, or a demon, depending on the theological predisposition of the observer and the broader social context. During periods of plague or war, such appearances were often interpreted as harbingers of doom. During times of relative peace and prosperity, they might be seen as divine blessings. Yet beneath these varying interpretations, the core descriptions of the phenomenon itself remained remarkably consistent: glowing, spherical, mobile, unpredictable, and potentially destructive. The Enlightenment brought a radical shift in how learned individuals approached mysterious natural phenomena. Beginning in the late 17th century, naturalists and early scientists began systematic observation and documentation, attempting to strip away supernatural interpretation in favor of empirical description. This period saw the rise of scientific societies that actively collected and compared reports of unusual phenomena. The Royal Society in London received numerous accounts of what they termed fireballs or lightning balls throughout the 18th century. These reports came from credible observers, including ship captains, military officers, and educated landowners who could describe events with precision and without immediate recourse to religious explanation. Maritime accounts became particularly valuable during this period. Sailors had long observed various electrical phenomena at sea, including St. Elmo's fire, the corona discharge that creates glowing auras around mast tops and rigging during thunderstorms. However, experienced mariners clearly distinguished between St. Elmo's fire, which remained attached to conductive surfaces, and true-ball lightning, which floated freely through the air. Ships' logs from the 18th and 19th centuries contain detailed descriptions of luminous spheres appearing during storms, sometimes descending from clouds to hover above the deck, before rolling along rails or dropping through hatches into lower decks. In 1753, the captain of a merchant vessel recorded an incident where a ball of light approximately 8 inches in diameter emerged from the ship's compass, drifted across the bridge, and exited through a porthole, leaving behind a strong smell of sulfur and causing temporary disorientation among the crew. These maritime accounts are particularly valuable because ship's officers were trained observers accustomed to recording unusual events with precision and without hysteria. Their logs provide timestamps, weather conditions, ship positions, and detailed descriptions of the phenomana's appearance and behavior. When these accounts are compiled and compared, patterns emerge that transcend cultural interpretation. The spheres are most commonly reported during thunderstorms, but occasionally appear in clear weather. They range in size from a few inches to several feet in diameter. They move horizontally more often than vertically, seemingly unaffected by wind. They can pass through solid materials without damaging them, or can cause significant destruction. They typically last from a few seconds to several minutes before dissipating or exploding. The 19th century brought both photography and increased literacy, expanding the pool of potential witnesses and introducing the possibility of visual documentation. However, the very emergence of photographic technology also introduced new questions about authenticity. Early photographs claiming to show ball lightning were often revealed as double exposures or other artifacts of the photographic process. This created a paradox that persists to the present day. The better our documentation technology becomes, the more sophisticated potential fakery becomes as well. The proliferation of cameras in the 20th century did yield some intriguing images and footage, but skeptics could always question whether what was captured was truly ball lightning or some other phenomenon, whether natural or artificial. Despite these challenges, the 20th century saw ball lightning transition from folklore to accepted scientific puzzle. Researchers compiled databases of thousands of reports, analyzed patterns, and attempted laboratory recreations. What emerged from this systematic analysis was striking. Reports from rural China in the 20th century described the same essential phenomenon as accounts from medieval England or ancient Rome. Cultural interpretation had shifted dramatically over the millennia, from divine messages to demonic manifestations to atmospheric electrical phenomena, yet the core observations remained constant. This cross-temporal and cross-cultural consistency is perhaps the strongest argument that ball lightning represents a genuine natural phenomenon rather than mass delusion or misidentification of common events. Contemporary researchers analyzing historical accounts have noted how the human mind struggles with phenomena that defy easy categorization. Ball lightning violated and continues to violate our intuitive understanding of how lightning should behave. Standard lightning is instantaneous, follows clear paths between points of different electrical potential, and dissipates immediately. Ball lightning persists, wanders, seems to possess agency in its movements. This apparent violation of natural law triggers deep psychological responses. Ancient observers reached for supernatural explanations because their worldview accommodated spirits and gods. Modern observers, lacking such frameworks, often report feeling profound unease or cognitive dissonance when confronting something that seems to behave impossibly. The journey from supernatural to natural explanation has not erased the mystery or the emotional impact of encountering ball lightning. Witnesses today, even those with scientific education, frequently describe feelings of awe, fear, or unreality when observing the phenomena. The human brain seeks patterns and explanations, and ball lightning resists both. It appears without warning, behaves according to no obvious rules, and vanishes before proper observation can be completed. This encounter with genuine natural mystery, with something real yet inexplicable, creates a psychological experience that transcends culture and erudition. The medieval monk who saw a fireball in his chapel and the modern physicist who observes one in a laboratory may invoke different explanatory frameworks, but both experience that fundamental human confrontation with the unknown. What we learn from tracing ball lightning through recorded history is not just about a particular atmospheric phenomenon, but about how humanity processes mystery itself. Each era clothing the same observations in contemporary interpretive frameworks reveals how powerfully culture shapes perception, yet the persistence of consistent core details across those frameworks points to an underlying objective reality. The luminous spheres that ancient Chinese scholars called dragon pearls, that medieval Christians saw as angels or demons, and that modern scientists recognize as some form of plasma phenomenon, are, in all likelihood, the same thing viewed through different lenses of understanding. The phenomenon remains consistent. Only our explanations change. For more than a century, the scientific establishment has grappled with an uncomfortable truth. Thousands of credible witnesses have reported seeing something that, according to our understanding of physics, should not exist. Ball lightning and atmospheric spooklights have occupied a peculiar position in the annals of science, a phenomenon too widely observed to dismiss entirely, yet too strange to accommodate within conventional theory. The initial response from the scientific community was predictable and, in retrospect, remarkably dismissive. When 19th century observers first began reporting luminous spheres floating through the air, often during thunderstorms but sometimes under clear skies, the educated elite had a ready explanation. These witnesses, they claimed, were victims of their own minds. Optical illusions, after images from lightning strikes, mass hysteria. Some physicians suggested that ball lightning was nothing more than a phosphene, a phenomenon of light perceived when the retina is stimulated by mechanical or electrical means, rather than by light itself. When people claimed to see glowing orbs, scientists said they were simply seeing the inside of their own eyes. This dismissal persisted even as the reports accumulated. Naval officers, airline pilots, meteorologists, university professors. The witnesses included trained observers whose professional credibility was otherwise unquestioned, Yet when they described encounters with ball lightning, their testimony was politely set aside. The problem was simple. Ball lightning violated too many established principles. Plasma, the ionized gas that composes lightning, should not be able to maintain a stable, spherical form at atmospheric pressure. It should dissipate almost instantly. Yet witnesses consistently described spheres that persisted for seconds or even minutes, floating through rooms, passing through windows, sometimes moving against the wind. By the mid-20th century, outright dismissal became untenable. Too many reports existed, too well documented, from too many credible sources. Science had to shift from denial to explanation, and thus began decades of theoretical speculation that would produce some of the most creative, and occasionally desperate, hypotheses in modern physics. The vaporized silicon hypothesis emerged in 2000 as one of the first comprehensive attempts to explain the phenomenon within known physics. Two New Zealand scientists, John Abrahamson and James Dennis, proposed that when lightning strikes soil or sand, the intense heat vaporizes silicon clumps. These vaporized particles, they theorized, become bound together in long chains through oxidation, creating a kind of floating battery of chemical energy. As the silicon slowly recombines with oxygen in the air, it releases energy in the form of light and heat. The beauty of this theory was its testability and its grounding in conventional chemistry. Laboratory experiments seemed to support the hypothesis. Researchers managed to create small, short-lived luminous spheres by vaporizing silicon in controlled conditions. The spheres glowed. They floated. They looked, at least superficially, like the ball lightning described in witness accounts. But the theory had problems. It could not explain ball lightning observed at sea, far from any silicon-rich soil. It could not account for spheres that appeared inside aircraft at high altitude, or passed through solid glass without breaking it. Most troublingly, it could not explain the sheer energy density reported in some cases, where ball lightning allegedly melted metal or left burn marks that would require far more energy than chemical oxidation could provide. Parallel to this, other physicists pursued radically different approaches. The microwave cavity hypothesis suggested that ball lightning was not a discrete object at all, but rather a region of space where microwave radiation became trapped in a self-sustaining pattern. This theory proposed that electromagnetic waves could, under certain conditions, form a standing wave pattern that created a visible sphere of ionized air. The microwaves would continuously reionize the air, maintaining the glow, while the spherical pattern would give the illusion of a solid object. This hypothesis had the advantage of explaining ball lightning's ability to pass through walls and windows. If it was merely a pattern of electromagnetic energy rather than matter, then non-conductive materials would pose no barrier. Yet the theory struggled with basic questions of energy supply. Where did the microwaves come from? How could they maintain such a precise, stable pattern in the chaotic environment of a thunderstorm? And why did ball lightning sometimes leave physical evidence behind, scorch marks and melted materials that suggested direct contact with hot matter rather than mere radiation? As frustration mounted, some physicists turned to increasingly exotic explanations. The nanobattery model proposed that ball lightning consisted of countless microscopic batteries, aerosol particles with chemically distinct layers that could store electrical charge. Like the silicon theory, this offered a chemical rather than purely electromagnetic explanation, but it required extraordinarily specific conditions to form. The statistical improbability of millions of identical nanobatteries spontaneously assembling in the right configuration seemed to some researchers almost as miraculous as the phenomenon itself. Then, there were the truly fringe theories. In 2008, a research team seriously proposed that ball lightning might contain antimatter. When antimatter encounters ordinary matter, the two annihilate each other in a burst of energy, and this team suggested that somehow, lightning strikes could create and temporarily contain small amounts of antimatter in a magnetic bottle formed by the storm's electromagnetic fields. The theory had the advantage of explaining the enormous energy density observed in some cases. Matter-antimatter annihilation releases far more energy than any chemical reaction. But it required mechanisms for antimatter creation and containment that seemed to belong more to science fiction than to atmospheric physics. What all these theories shared was a common difficulty. None could be definitively proven because the phenomenon itself remained frustratingly elusive in controlled settings. Laboratory recreation of ball lightning became something of a holy grail in plasma physics. Hundreds of attempts were made. Researchers fired electrical discharges through every conceivable medium. They vaporized every material imaginable. They created electromagnetic field configurations of Byzantine complexity. Occasionally, they produced something that looked vaguely similar, small glowing spheres that lasted a second or two. But nothing that truly replicated the full range of reported characteristics. Nothing that persisted for 30 seconds while floating through a room. Nothing that passed through solid matter. Nothing that matched the energy density of the more dramatic reports. The failures accumulated. Each failed experiment narrowed the possibilities slightly, but brought researchers no closer to a comprehensive explanation. Some physicists began to wonder whether laboratory recreation was fundamentally impossible, whether ball lightning required the vast chaotic energy of a real thunderstorm, conditions that could never be safely replicated indoors. Then came 2012, and everything changed. In the Qinghai province of China, researchers from Lanzhou University were studying conventional lightning with video cameras and spectroscopic equipment when something extraordinary happened. A sphere of light appeared in their camera's field of view, just as a lightning strike hit the ground. For the first time in history, ball lightning was captured not just on video, but with spectroscopic analysis. The significance of this moment cannot be overstated. Spectroscopy reveals the chemical composition of light sources by analyzing which wavelengths are present. It is one of the most fundamental tools of modern science, and it had never before been applied to ball lightning because the phenomenon had never been captured under the right conditions with the right equipment. The data was remarkable. The spectrum showed bright emission lines for silicon, iron, and calcium. The silicon findings seemed to support Abrahamson and Dinnis's theory, but the presence of iron and calcium in such quantities suggested something more complex. The ball persisted for approximately 1.64 seconds, traveled roughly 15 meters, and appeared immediately after the lightning strike hit soil. Here, finally, was direct scientific evidence. Not anecdotes, not second-hand reports, but reproducible data captured by calibrated instruments and published in a peer-reviewed journal. Yet even this breakthrough left more questions than answers. The Chinese data supported aspects of the silicon hypothesis, but did not confirm it definitively. The spectroscopic signature was consistent with vaporized soil, but the formation mechanism remained unclear. How did these vaporized elements organize into a stable sphere? What maintained its structure? Why did it persist for only 1.64 seconds when witnesses often report much longer durations? Was this particular instance somehow different from other reports of ball lightning? The Chinese video became both a milestone and a reminder of how much remained unknown. For the first time, scientists had proof that ball lightning was not mere hallucination or misidentification, but this proof came from a single observation of a relatively short-lived instance. The phenomenon's rarest and most dramatic manifestations, the kind that passed through aircraft fuselages or floated through buildings for minutes at a time, remained as mysterious as ever. Leading physicists began to acknowledge publicly what many had privately admitted for years. Ball lightning represented a genuine challenge to our understanding of plasma physics. Physicist David Finkelstein stated it plainly when he said that ball lightning was the most enduring unsolved problem in atmospheric physics. Plasma physicist Carl Stephan noted that the phenomenon continues to defy explanation by conventional physics. These were not fringe researchers or publicity seekers. These were established scientists admitting that something witnessed by thousands, something captured on video and analyzed spectroscopically, remained theoretically unexplained by modern science. This admission carried profound implications. It suggested that our models of how matter and energy behave at atmospheric pressure and temperature, conditions we encounter every day, were somehow incomplete. Ball lightning was not some exotic phenomenon requiring particle accelerators or astronomical observations. It happened in the everyday world, in people's homes and offices, yet it defied explanation. The tension inherent in this situation continues to drive research. Something about the complexity of the formation process, the specific conditions required, eludes our current theoretical frameworks. Perhaps multiple mechanisms can produce similar effects, which would explain why no single theory seems to account for all observations. Perhaps our understanding of plasma behavior in complex electromagnetic environments is simply insufficient. Or perhaps ball lightning points towards some aspect of physics that we have not yet imagined, some interaction between electricity, matter, and energy that occurs only under very specific, difficult-to-replicate conditions. What remains clear is that ball lightning stands as a monument to scientific humility. It reminds us that the natural world still holds secrets, that phenomena can exist in plain sight, yet remain beyond our theoretical grasp. Thousands have seen it. One team has measured it. Yet we still cannot fully explain it, cannot reliably create it, cannot even agree on what, fundamentally, it is. In the space between observation and explanation, ball lightning glows on, a puzzle wrapped in light. When a person stands at the edge of a dark field and watches an unexplained light dance across the horizon, something profound happens inside the human mind. The experience triggers a cascade of psychological responses that scientists and researchers have only begun to understand. What makes these encounters so powerful is not just the strangeness of the light itself, but the way our brains struggle to categorize something that exists outside our normal frames of reference. The human brain is fundamentally a pattern recognition machine. From the moment we wake until we sleep, our minds constantly scan the environment, matching what we see against an internal database of familiar objects and experiences. This ability kept our ancestors alive, allowing them to distinguish between rustling grass caused by wind and rustling grass concealing a predator. But this same mechanism, so crucial to survival, can become a source of confusion when confronted with truly anomalous phenomena. Consider the witness who arrives at a known spooklight location with a set of expectations already formed. They have read accounts, studied photographs, perhaps spoken with others who claim to have seen the lights. Their mind has constructed a template of what to expect. When lights appear in the distance, the brain immediately begins its categorization process. Is this a car headlight? A reflection? Something else entirely? The expectation effect is powerful enough that researchers studying witness testimony have documented cases where people reported seeing details that aligned with folklore descriptions, even when video evidence later showed something quite different. Yet this psychological framework cannot explain every encounter. The cases that resist easy dismissal often share common characteristics: multiple witnesses observing the same phenomenon simultaneously, physical evidence left behind, or instrumental readings that confirm something unusual occurred. These cases force us to consider that while psychology explains much, it does not explain everything. The fear response to ball lightning and similar phenomena provides a window into how humans react when natural law appears to bend. Witnesses consistently describe a particular quality of terror that differs from ordinary fear. This is not the fear of a known threat, like encountering a dangerous animal. Instead, it resembles the deep existential unease that comes from realizing the world operates by rules we do not fully understand. One witness who encountered ball lightning inside her home during a thunderstorm described the experience as fundamentally reality-breaking. The sphere of light drifted through her kitchen, passed through a closed window without breaking the glass, and vanished. For weeks afterward, she struggled with a lingering sense that the solid, predictable world she had always known was somehow less stable than she had believed. This reaction makes evolutionary sense. Our ancestors survived by developing accurate mental models of how the world worked. Fire behaves in certain ways. Water follows specific rules. When something appears to violate these rules, it triggers alarm because it suggests our mental model is flawed, leaving us vulnerable to threats we cannot predict or understand. The awe that often accompanies the fear stems from the same source. We are witnessing something that expands our conception of what is possible, and that expansion is both terrifying and exhilarating. The role of local folklore in shaping these experiences cannot be overstated. Communities that develop around spooklight hotspots create rich narratives that influence how residents and visitors interpret ambiguous stimuli. The Marfa Lights in Texas, the Brown Mountain Lights in North Carolina, the Paulding Light in Michigan. All of these locations come packaged with stories. Some tales speak of lost miners carrying lanterns, searching eternally for their way home. Others invoke Native American spirits or residual energy from tragic events. When a person visits these locations, they do not arrive as a blank slate. Their perceptions are filtered through these narratives. Research into expectation effects demonstrates how powerfully prior knowledge shapes perception. In controlled studies, participants shown ambiguous visual stimuli interpreted them differently based on what they were told to expect. The same principle applies in the field. A light moving erratically at a known spooklight location might be identified as paranormal by someone familiar with the local legends, while the same light observed in a different context might be dismissed as a distant vehicle or atmospheric phenomena. But here again, the psychology grows complicated when we examine specific cases. The Hessdalen lights in Norway represent a compelling example of how scientific investigation can confirm that something genuinely anomalous occurs at certain locations. Researchers established an automated monitoring station equipped with cameras, magnetometers, and spectrum analyzers. The instruments documented lights that appeared and disappeared without corresponding to any known aircraft, vehicles, or conventional sources. Multiple cameras triangulated the lights' positions, confirming they occupied real three-dimensional space rather than being optical illusions or reflections. Witnesses' accounts aligned with instrumental data, suggesting their perceptions were accurate rather than psychologically constructed. This brings us to the question of why certain locations become hotspots. Geography plays a role, certainly. Areas with clear sightlines across flat terrain or valleys allow lights to be visible from great distances. Atmospheric conditions unique to specific regions might contribute to unusual optical effects. But psychology adds another layer. Once a location gains a reputation, it attracts attention. More people visit, spend more time watching, and report more sightings. This creates a feedback loop where increased observation leads to increased reports, which attracts more observers. The psychological need for explanation manifests differently in different people, creating the divide between believers and skeptics. Some individuals possess a high tolerance for ambiguity. They can observe something unexplained and remain comfortable not knowing what they witnessed. Others experience cognitive discomfort when confronted with unresolved mysteries and feel compelled to reach a conclusion, even if the available evidence is incomplete. Skeptics often serve a valuable function by rigorously examining claims and identifying cases where conventional explanations fit the facts. Many reported spooklights have been traced to car headlights viewed under specific atmospheric conditions, or to other mundane sources. The critical approach helps separate genuine anomalies from misidentifications. However, skepticism can sometimes harden into reflexive dismissal, where the possibility of anomalous phenomena is rejected not based on evidence but on prior commitment to a worldview that cannot accommodate such things. Believers, meanwhile, may too quickly embrace paranormal explanations without adequately considering conventional possibilities. The human mind craves narrative and meaning. An unexplained light becomes more satisfying when woven into a story about spirits or unknown forces than when left as simply an unexplained light. This tendency toward narrative construction is not a flaw, but a fundamental aspect of human cognition. We are storytelling creatures. The danger lies in confusing the stories we tell with established facts. The most intellectually honest position acknowledges both the power of psychological factors and the reality that some cases resist psychological explanation. When a trained meteorologist observes ball lightning at close range, notes its characteristics, and provides a detailed account that aligns with instrumental data and other witness testimony, dismissing the experience as mere misperception becomes difficult. When multiple independent witnesses, with no communication between them, report seeing the same unusual light from different vantage points, and their descriptions correlate in specific details, the psychological explanation grows strained. Physical evidence further complicates purely psychological interpretations. Cases where ball lightning has left scorch marks, damaged electrical equipment, or produced measurable electromagnetic effects suggest something real occurred beyond perceptual error or expectation bias. The challenge for researchers is distinguishing between cases where psychological factors fully explain the experience and cases where genuine anomalous phenomena occurred but psychological factors influence how the experience was interpreted and remembered. Memory itself plays a crucial role in how these experiences are understood and transmitted. Studies of eyewitness testimony reveal that memory is not a recording, but a reconstruction. Each time we recall an event, we rebuild it from fragments, and those fragments can be altered by subsequent information, suggestions from others, or our own unconscious editing. A witness who sees an unusual light and later reads accounts of similar phenomena might unconsciously incorporate details from those accounts into their own memory. This does not mean the witness is lying, or that nothing unusual occurred, only that the remembered experience and the actual experience may differ in important ways. The emotional intensity of spooklight encounters can actually enhance certain aspects of memory while distorting others. High-arousal events tend to be remembered more vividly than mundane experiences, but stress and fear can narrow attention, causing witnesses to fixate on certain details while missing others entirely. A person frightened by an approaching ball of light might recall its color and movement with great clarity while having no memory of surrounding environmental details that could help investigators identify what they saw. Understanding these psychological dimensions does not diminish the significance of spooklight phenomena. Rather, it helps us appreciate the full complexity of the experience. A person who witnesses something that appears to defy explanation undergoes a genuinely transformative experience, regardless of whether the light had a conventional or anomalous origin. The fear, the wonder, the re-evaluation of assumptions about reality, these responses are authentic and meaningful. They reveal something important about human consciousness and our relationship with the unknown. The path forward requires holding multiple truths simultaneously. Psychology explains much about why people report seeing spooklights and how cultural context shapes those reports. Expectation effects are real and powerful. Memory is malleable. Pattern recognition systems in the brain can generate false positives. And yet, some phenomena appear to exist independent of these psychological factors, confirmed by instruments and multiple observers, resisting easy categorization. The challenge is developing the discernment to distinguish between the two while respecting both the power of human psychology and the possibility that nature contains genuinely mysterious phenomena we do not yet understand. In the pine forests of North Carolina, the Brown Mountain Lights continue their nightly dance, just as they have for countless generations. In the storm clouds above our cities, ball lightning still appears without warning, defying our attempts to predict or capture it. And in laboratories around the world, scientists continue to propose theories, build models, and design experiments to explain these phenomena, knowing full well that each answer seems to spawn a dozen new questions. This persistence of mystery, even in an age when we can peer into the hearts of distant galaxies and manipulate individual atoms, tells us something profound about the nature of knowledge itself. Despite all our technological advances, despite satellites that monitor every wavelength of radiation and sensors that can detect the faintest electromagnetic whisper, we still cannot say with certainty what causes a glowing sphere to float through a living room, or what makes lights appear year after year in the same remote valleys. This is not a failure of science. Rather, it is a humbling reminder that the universe does not organize itself according to our convenience, and that some phenomena resist easy categorization precisely because they challenge the assumptions embedded in our questions. The study of ball lightning and spooklights has taught researchers something valuable about the limits of the scientific method when applied to rare, unpredictable events. Traditional science works best with reproducible phenomena, with effects that can be summoned on demand in controlled settings. But what do we do when the subject of our study appears only when it chooses, following patterns we cannot yet discern? The witnesses, who have encountered ball lightning, did not request the experience. The lights that dance above Marfa or Brown Mountain do not perform for cameras or measurement devices. They exist on their own terms, indifferent to our need for data. This creates a peculiar situation where the very standards that make science rigorous become obstacles to understanding. Eyewitness testimony, normally considered the weakest form of evidence, becomes precious because it is often all we have. Anecdotal reports, usually dismissed in favor of controlled experiments, must be carefully cataloged and analyzed because reproducible lab conditions remain frustratingly out of reach. The scientific community finds itself in the uncomfortable position of working with the kinds of evidence it has spent centuries learning to treat with skepticism, all while trying to maintain the rigor that separates genuine inquiry from speculation. Yet this discomfort has proven productive. The challenge of studying elusive phenomena has pushed researchers to develop new methodologies, to think creatively about evidence, and to remain humble about the provisional nature of all scientific knowledge. The assumption that every mystery will yield quickly to modern instruments has given way to a more patient understanding that some answers require not just better tools, but entirely new frameworks for thinking about the questions themselves. Future research into these luminous mysteries will likely benefit from technological advances we can barely imagine today. Networks of automated sensors, equipped with cameras that capture multiple wavelengths simultaneously, and spectrometers that analyze chemical compositions in real time, may eventually provide the comprehensive data that has eluded previous generations of researchers. Artificial intelligence might detect patterns in the appearances of these lights that human observers have missed, correlations between atmospheric conditions, geological factors, and electromagnetic fields, too subtle for us to notice. Advances in plasma physics and atmospheric chemistry may offer new theoretical frameworks that make sense of observations that currently seem contradictory. But technology alone will not solve these mysteries. What is also needed is a willingness to question assumptions, to consider possibilities that seem unlikely, and to follow the evidence even when it leads in unexpected directions. The history of science is filled with phenomena that were dismissed as impossible until someone looked closely enough to see that they were real. Ball lightning itself was considered a myth by many scientists well into the 20th century. The idea that continental plates moved across the Earth's surface was ridiculed before it became the foundation of modern geology. The lesson is clear. Nature is under no obligation to conform to our current understanding, and the impossible occasionally turns out to be simply the not yet explained. These dancing lights also serve a function beyond their scientific interest. They keep alive a sense of wonder in a world that can sometimes feel entirely mapped and measured. In an era when satellites photograph every square meter of the Earth's surface and search engines promise immediate answers to every question, there is something valuable about knowing that mysteries remain. The lights remind us that our ancestors, who watched the same unexplained glows in their skies, were not simply primitive people frightened by natural phenomena. They lacked the sophistication to understand. They were human beings encountering genuine mysteries, experiences that remain mysterious even now. This recognition connects us across time to everyone who has stood beneath strange lights and felt that peculiar mixture of fear and fascination that accompanies the unexplained. The sailor who saw ball lightning dance across the rigging of his ship in 1700 was experiencing the same phenomenon that still appears to pilots and power station workers today. The Cherokee people who wove stories around the Brown Mountain Lights were observing the same displays that draw curious visitors to North Carolina in our own time. The mystery does not diminish us. Instead, it places us in a long tradition of humans who observe, question, and wonder. What these phenomena ultimately reveal is that acceptance of the unknown is not the opposite of scientific thinking, but rather its necessary companion. The scientist who admits uncertainty is not abandoning reason, but embracing intellectual honesty. The researcher who acknowledges the limits of current understanding is not giving up but rather defining the frontier where future discoveries wait. Every solved mystery began as an unexplained phenomenon that someone took seriously enough to investigate. Ball lightning and spooklights may represent the unsolved mysteries of today, but they might also be the breakthroughs of tomorrow, waiting for the right combination of observation, theory, and technological capability to finally yield their secrets. And if some of these mysteries never fully resolve, if certain questions prove resistant to even our most sophisticated approaches, perhaps that too has value. Perhaps we need reminders that the universe contains depths we have not yet plumbed, phenomena that operate according to principles we have not yet grasped. Perhaps the presence of mystery keeps us appropriately humble, prevents us from mistaking our current maps for the actual territory, and maintains the sense of wonder that motivates scientific inquiry in the first place. So the lights continue their ancient dance. In the Marfa Desert, in the Norwegian valleys, above the mountains of North Carolina, and in storm systems around the world. They appear and disappear, glow and fade, following patterns we cannot yet predict. They wait in the darkness and the storms, these balls of light and mysterious glows, patient as only natural phenomena can be patient. They will still be there when we develop new theories, when we deploy new instruments, when we ask better questions. They have waited this long. They can wait a while longer. And in that waiting, in that persistence of mystery despite all our efforts to dispel it, lies a message worth hearing. The world is still larger than our understanding of it. Wonder still has a home in our reality. The questions that matter most sometimes take longer to answer than a single human lifetime. And that is not a cause for despair, but for a kind of joy, the recognition that we live in a universe still capable of surprising us, still holding secrets, still inviting us to look more carefully, think more deeply, and remain forever curious about the dancing lights that refuse to be explained away. That's where this journey ends for tonight. If you made it all the way here, subscribe and hit the bell for more long-form stories like this. Check out the videos on screen.